In this lesson, we'll focus on avoiding collisions. After completing this lesson, you'll be able to use shaft and holder clearance to avoid part collisions. Let's carry on with the file from our previous example, and let's talk about ways in which we can avoid collisions when we're dealing with our multi-axis toolpaths. First, we're going to edit the last flow operation, and I want to go into my passes, and I'm going to change the number of step overs down to something a little bit more manageable. We're going to change that to 4, and we're going to change our tolerance value to 4 and turn off smoothing. These will help us calculate the toolpath a little bit quicker. Next, I'm going to go into my tool section and turn on shaft and holder. I'm going to reduce the holder clearance down to something a little bit tighter at 0.05 and the shaft clearance leave at 0.04 and say OK. We're going to allow it to recalculate this toolpath, and because we reduced the number of step overs, it should calculate a bit faster. But remember, when we looked at this for the first time, we had a lot of tool and holder collisions with the surrounding geometry. So there is a lot for it to calculate here in order to avoid those areas and figure out a new strategy for getting to the geometry that we want to machine. With the toolpath calculated, now let's go ahead and take a look at Simulate. I'm going to hide the model so we're only looking at the stock, and notice that we do have one collision identified in here. But let's play through and see how the tool cuts and accesses this geometry. So you can see, unlike the original creation of this toolpath where it simply just took the holder through the mounting plate and the surrounding geometry, now it's taken a lot of time to go through and calculate where it can and can't go. You'll notice that we still did have one collision with the holder, so we would need to continue to explore these options, maybe make some adjustments to the shaft and holder parameters to give it a little bit more clearance. But this is going to be a much better option than the first one, where it was simply just tearing through all the surrounding geometry. Likely the best course of action is to go back into the toolpath, make adjustments to the number of passes so that way it only goes past once. I'm going to change the fragment length to 0. And then what we can do is we can allow it to go back and calculate that based on these parameters. I'm not going to do that because it does take quite a bit of time for it to recalculate these every time, so I'm going to select Cancel. But keep in mind that when we're using this multi-axis flow toolpath, we have a lot of options at our disposal. With a part like this that has a lot of segmented faces, it can take a little bit of time for us to select the number of faces that we want to machine. We certainly don't want to select the entire body and let it just go at it with a multi-axis flow toolpath. But it can be a great option after doing something like a 3-axis adaptive clearing to remove a bunch of material, then going back in with something like a multi-axis flow to clean up certain areas of the design. From here, I'm going to make sure that my file is saved before I move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.